Yes, good morning once again. Good morning. This morning, once again, we look at the structure of the nephron. We take a look at the structure of the nephron. Like we have already said in our first video, that the nephron is the functional unit of the kidney, because one of the main functions of the kidney is to filter blood, and that structure that helps the kidneys to filter blood is the nephron. And that's why the nephron is considered as the functional unit of the kidneys. And from our recent structure of the kidney, as we draw to say the kidney is bean-shaped structure, and we said inside this kidney, in the layer called the medulla, we have the renal pyramids. And we said in these renal pyramids is where we have the nephrons, and they are over millions plus. There are very many nephrons found within a pyramid of a single kidney. And we said these pyramids are due to minor calyces, which form major calyces to renal pelvis and pass out waste fluids, which we call urine. So now we're trying to look at this nephron, what we are seeing here. We have put the nephron here inside the renal pyramid, and we want to see how does it look like, because we have said it is the functional unit of the kidney, and its main function is formation of urine. And we also said that the kidney, the nephron, consists of, so shall we begin by labeling as we move together. So here in simple structure here, I've tried to illustrate the heart. Let me label it with letter H for its identification. So we know the heart pumps blood continuously, oxygenated and deoxygenated. Oxygenated blood is pumped through the aorta to supply other parts of the body. And amongst those parts of the body that need to be saturated is the kidney. And how does the kidney get this blood? Is blood leaving the heart through the aorta. So from the aorta, enable does go, so that's the aorta. So from the aorta we get a branch from the aorta, an artery that has to enter the kidney, because we say this all is in one pyramid of the kidney. So this blood from the heart is taken out through the aorta, and then it leaves the aorta to enter now the kidney. So it is like the aorta going like this, then we have the kidney here like this. So blood is leaving the aorta to enter the kidney. So as it is entering the kidney at what we call the renal artery. So this one here becomes the renal artery. And from our previous lectures we have said blood vessels move from arteries to arterioles, to capillaries, to venules, then veins. So as this renal artery enters deep into the kidney, it forms what we call arteriole or arterioles. And that arteriole that enters deep into the kidney, is what we call the afferent arteriole. So the afferent arteriole is going to take blood from the renal artery to the inside the kidney. So this becomes our afferent arteriole. And then it enters inside our renal pyramid where we have the nephron. And then as it is entering inside, from arterioles now we get to capillaries. So capillaries, so these are our capillaries, but they are called glomerular capillaries. So this becomes glomerular capillaries. They are called glomerular capillaries. All called glomerular capillaries. Now, from what we know that glomerular capillaries are permeable, and being permeable, it means they let substances that are permeable or that are small enough to go through to descend down, and those that can't go through to remain dropped upside or upwards. So these are the glomerular capillaries that form the closed end. So this nephron consists of an open end and a closed end. So our closed end is this here, something like this. So what we have, this is what we call the Bowman's capsule. So it is this one here, and the Bowman's capsule, it is closed. That's why we are having the capillaries. So this is the Bowman's capsule. Then at the Bowman's capsule, we have its lower layer here, called the glomerular. It is this one here. So as blood now has reached here the glomerular or the glomerular capillaries, permeable substances such as sodium ions, calcium ions, chloride ions, potassium ions, ammonia, glucose, and others are filtered out. So, because they are permeable, they will be filtered out. Whereas those substances that are not permeable, such as blood cells, red blood cells, white blood cells, platelets, hormones, will not be filtered here, either because they are too big to be filtered, or they spend less time at the glomerulus. So they will be passed out from the glomerular capillaries by process we call ultrafiltration, which you shall see next in the course of your information. And then it is taken out and then brought here in the Bowman's capsule here. So this fluid will be filtered out into the Bowman's capsule. And from the Bowman's capsule, now we form what we call the proximal convoluted tubule. So the proximal convoluted tubule connects from the Bowman's capsule like this, and it continues from what we call the loops of Henry. So we have the loops of Henry, which are two. We have the one that is going down, we call it the descending loop of Henry, and where it is going up, this one, which we call the ascending loop of Henry. So we have the descending loop of Henry and the ascending loop of Henry. The descending and ascending all are called the loops of Henry. So it continues, the ascending ascends up from another part that we call the distal convoluted tubule. The distal convoluted tubule. And the distal convoluted tubule processes this fluid, what we call the collecting ducts. The collecting ducts. And the collecting duct now, we pass this fluid out here through the minor callus to the major callus, renal pelvis, and then it is passed out through the ureters to the urinary bladder, and later passed out as waste urine. The substances that remain here, because they are too big, such as red blood cells, platelets, hormones, and some other enzymes, because the body still needs them, they are retained and the glomerular capillaries, and then taken throughout through what we call the efferent arteriole. So the efferent arteriole descends down from capillaries, which we call the peritubular capillaries. These are the peritubular capillaries, which takes substances that are not absorbed, and they are glomerulus, the glomerular capillaries, and they are taken out, and then they join back to the venous system. So this is our inferior vena cava, and then they be taken back to the heart for circulation. So this is how fluids rotate or circulate within the kidneys and nephron in particular. this is the mechanism. From the heart, renal artery, afferent arteriole, renal capillaries, amniocenteral substances to the proximal convoluted tubule, the descending group of Henle, to the ascending group of Henle, distal convoluted tubules, and collecting that they are passed out. The impermeable substances taken through the efferent arteriole, through the ventricular capillaries, because they are needed by the body, they are taken up and returned to the heart for circulation, which will go to other parts of the body for the effective functions. So this has been the structure of the nephron. Next, video 3, we shall see the process of urine formation, or how is urine formed, the steps of urine formation after describing this. Thank you so much once again for following up our YouTube channel and other social media handles. Deruki Abdegeka is my name. We meet again in our lecture that follows.